Well, hello, welcome to the show. Do the click, like, subscribe, hit the notification bell. It helps me with the algos. Now that we got that out of the way, it's going to be a long video. I'll just be honest with you. It's going to be a long video, but I'll put chapter marks in there so you can skip through to the parts that interest you. Because whether or not you have a welder or a backwashing filter or something like this really is not the issue. I'm doing this so you can see kind of the problem solving, how you might be able to fix some stuff. And of course, because I'm conservative, I care about my environment, my world, and I just don't want to throw anything more away than I have to that ends up in the garbage dump. You know, just if we can, let's what I say is 4 R's. We recycle, reuse, repurpose. I like to repair when possible. Now let's roll title. Here's the problem. It's all idiot behind the screen type of issue. The filter, the 1 cubic foot filter, was old. The timer board, the control board went out. It's what operates the backwashing, the time of day type of thing, day of week. And it had gone bad. The valve's not leaking. The plumbing's not leaking. Everything's good. It's been recently changed out on its media, so it's all refreshed. It's just my buttons quit. And this, I think I started this back or found out about this in 2021, the last time the tank overflowed. So I had taken the thing apart and taken the board in and then called my supplier, Rock City Machine in Nashville, who has a lot of well parts, and they're good. They're a little high, but you know, that's what they do. And this is a specialized type of function. See if I can get the control board. And they didn't call me back, and another couple months passed, and then it did. And then I eventually somewhere I lost interest and got tired of looking at this control board that the buttons didn't work that was on the table in the kitchen, and I chucked it. I just went ahead and threw it away because I just buy a new one, right? I should be able to just buy a new one. I could probably repair it, go to DigiKey or Newark Electronics or something and buy new buttons for it and desolder the others. But, that's a little bit of trouble. Let's just throw it away. And it looked a little sketchy on the back in places where it looked like it may have had some oxidation that weren't properly coated, conformally coated. So that board was gone, never to be found again, and Rock City never called me back because there is no solution to it. I figured that out when I called the manufacturer, and they couldn't even find the part number for this particular filter. So eventually we discovered that we couldn't get it. We couldn't get the part. It wasn't available. And I said, well, how about just giving me a new valve head? Well, the new valve heads don't fit the old bottles, so that wouldn't work. I'd have to go to a full thing. What about just the parts to convert it? I'm pretty mechanically and electrically inclined. Maybe you can just give me the parts. So they give me the parts, and they work up to about $600, except you can't actually get the parts. I have part numbers, but there's no one will actually sell you the parts, including the manufacturer. So that whole thing was a waste of a month or two trying to figure out what to go. So we could buy a new filter. We would just need to replumb it and hope it didn't leak and go through all the hassles with trying to get unions to match and physical support and all that kind of stuff. We could do it, and they start about $1,200, $1,500 for a filter, and you pay tax, and you'd have to get it or pick it up if it's local, which is possible, but we could do that. Or I could get a Chinese one for about $680. I think I saw was the cheapest one. Gosh knows if it's going to last 20 years or if you can get parts for it. And of course you have to pay freight. And by the time you pay freight for this great unknown, the reality is it's going to cost you about $1,250, $1,500. So if I can, why can't I let's see if we can make the old one work. So here we have our little proof of concept as we go around, and let's see what it does. Well, it's not very exciting, but we did get our proof of concept in. Our little switch came in yesterday. Let's drive the motor full revolution. Put a little red paint right here. This is apparently a stop, and I don't know what BR is, and BF or BW, I guess, is backwash and reverse. I don't know what these things are. But I do know that the cam, as it goes around, would operate the valves in the back and flush it out through this one right here. This is the waste for the backwash. And we do have it set up on the top. A very simple way. We can turn this off if we got to work on the filter. We can put it on bypass if we need to, yada, yada, yada. But yeah, we just rigged up some wires to see if it would work. I did add this switch in. Went to Amazon looking for some micro switches, and I got some. One of them's got the little arm on it, one of them doesn't. So what I did notice that there is on the cam, at one spot, there's just one little tab that appears like somebody may have thought about using it for home or the start position, and that's what I'm using. So all it does is we can put power. Once we get it started, the switch relaxes because it's not on the tab, and that gives it power till it comes around till it turns itself off again. Perfect one revolution type thing. Doesn't take a days, a week, but I got a plan for that. I'll show you after a while. Well, now that we proved that we can actually get the valve off of park all the way around the cycle and back and stop it where we want it to stop, now we have to figure some way to control it. So I do have a sprinkler timer that I use when I built an automatic goat waterer. Yeah, because we have a pond, but it ran dry, and so somebody has to make sure the goats don't, thirst to death. So I use a sprinkler timer and a sprinkler valve controller, and it would do our time of day. So I've got the function in the building. I just got to figure out how to integrate that. So this is the wiring diagram. Now, you might have heard such things such as rough framework or back of the fag pack kind of plan, or a bar napkin plan, that kind of thing. That's a basic thing. So it's a very rough draft. It's just a basic idea. What can we do with it? That's kind of what our particular wiring diagram is. And I'll run through it real quick. This over here is just physical notes of where stuff is for me to wire this. This is a representation of the new switch that I bought from Amazon that the thing didn't come with, to see if in fact the park and start cycle, I could run it off of just this switch. Yes, I could. We just saw that. We need a timer, not a timer, but a latcher right here. We could also have maybe done it with a separate timer, but that got to be a lot of trouble. DIN controller, yeah, probably could have run a DIN controller, but have you priced a decent quarter DIN or eighth DIN controller lately? Yeah, we're talking several $100s. I did this for chump change, so to speak. It's just cheap Amazon basic parts. But right here, we'll go back to it. This is a Chinese illuminated switch. Black and the red are the light, and these are the contacts, as you see. Common, normally open, normally closed. That's on my little manual switch. The base, because I'm old and I can't see very well, I had to get it under light to mark down my numbers because I can read the relay. Yeah, so here's our timer on this side. Very rough working sketch. It works to the minute, which by itself would be okay. We've already seen that we could make it run a complete cycle and stop on its own with a cycle switch, this new one that I bought and put on there. It was made for it. It just wasn't populated because it had a newer version of a time of day timer on it. That's what went bad. So we know that we can make it work one revolution. So we just can control our day of backwash in time by using like station 3. So we've got station 1 for the goats here, and we use station 1 for the backwash. There we go. And that would make it go round. The problem that we have is this has a 1 minute increment. That's why we had to have that cycle switch. Because this RPM, however it goes, it would have to stop perfectly on the position we want it and never get out of sync, never lose power, never have a lightning flash or something, because there'd be no way to sync it back up to the forward position. That's what we use this little switch for. And it's very, very simple, very rudimental. We've got power on one side of the motor. We take power and run it through that little switch. And when we're in park position, the normally open is closed and the normally closed is open. That's this guy. So we pass power this way, and that allows us to give us a green light for the forward function to tell us, hey, you're in park or forward or whatever, you're in normal filtering position. That's how that works. And we're not operating any motor because the motor is disconnected. It has 3 possible things that can make it run. One is the latching relay, one is that park cycle switch type thing, and the other one is the timer. And all we need with a timer, we can start a cycle with 1 minute. We turn it on, gets out of position, and then this guy the switch, this guy, handles all the work. While it's in forward position, the green light is on, so we got power through here. It rotates itself out of position, and then this brakes, turning the green light off, and the motor is turned on. That would work. That would how it works. So we turn that motor with the timer. It's going to do all that. So how will it work if we wanted to manually run it? Because we know we can get it back to park with just that switch. We can start it with this one, and we are synchronized the way it is going to work. So we want a manual cycle, right? We want indication of where we are. So we've got indication that's in park. Well, that's with our green light, separate light. We bought a momentary switch, and what that momentary switch will allow us to do is if in the proof of concept, I just closed the switch and let it run. And it ran all the way around and it stopped. And then if we use a timer, we just parallel that switch to get it off of the dime. And once it's off of the dime, then it runs around until it gets back home. A manual switch would have to do something like that. The concept is I'd push the button and it would let it get off the go. The problem is when it takes a few seconds to get off of park and trip that switch, that cycle switch that you saw me add. It takes it a few seconds, 15, maybe closer to a minute. I don't know what it is. It's going to take a while to do that. And I don't want to sit there like an idiot and have to hold that button. Now you might say, well, why don't you just put a button that you push and stays on, two position, off and on. Well, because then if I turn it on, it would never turn off. I'd have to manually go back and turn the stupid thing off. And again, we've got it proving that it knows how to go back and reset to forward position and stop. That's good. And we know our timer can handle our time of day and day of week type function. We just need to make it manual work. Let's go back and look at this. This is where this little relay comes into play. The idea was I pushed this little button because our start position, this is not powering, this is open and this is closed. We're in rest, we're in park. So we have power to our green light. We also have power approaching our latching relay coil, but we don't have a closed path to complete the circuit. When we push that, momentarily just push that little button, we do that. It energizes that latching relay, which will then temporarily give us power on this set of contacts, turning our motor on and our little red light. Is it a red light? Yes, I think it's red light that's part of our switch on. But if we let go of it, the light's going to go out and it's just going to stop if we don't get out of park and make this power continue. So how we do it is we take the coil, we take one set of contacts and we jump that switch so that as soon as we push the button, this has already got the green light on. We allow the latch relay to be powered. It latches itself. We can release the button because the relay is holding itself. This is holding it, and we're going to hold power onto the motor as we rotate it off of park into the cycle. As soon as it does, this switch breaks, green light goes out. The motor continues because now we're using this guy to hold it until we go all the way around the cycle. And of course, this is also powering the red light in the switch to tell us that we're in. If you like this content, please go to calldeltosell.com, find the tab that says on YouTube, click it, and it'll open up a page of QR codes. There you can use a smartphone to scan and get to the YouTube page, or you can just mouse over and click it on a PC. There you'll be able to subscribe to this little button over here and click the notification red light in the switch to tell us that we're in backwash mode and it's powering the motor to make sure the motor keeps going. So that's the concept. But what you probably ought to ask yourself is that old fat guy on the internet, does it actually work? Well, that's what the next segment is. We're going to watch it. I do clip some of the time out because it takes like 5-6 minutes for a cycle. So we're going to just chop it out and see if the lights blink and they do what they're supposed to do and see if it'll actually come back and stop. Let's do that, and then we'll wrap up the video. Well, I don't know if we can tell, but we just painted that, not matte, whatever satin I guess it is. It's not gloss. I didn't want it gloss. It's too scratched up and beat up for that. And flat or matte gets a little bit rough, so maybe it might catch stuff on it. So I'm cleaning it up.
Doesn't have to be, but you can see, oh, that really shows up better on camera than it does in real life. That little color right there is another spot. Something dripped on it, probably glue, when I was rushing trying to get the water back on so that the people in the house could flush or whatever back years ago. You can see part that we didn't get the light on worked pretty good, keeping from turning that gamer PC yellow, but I don't know if you can see just how yellow that is, and we're gonna paint it black just for the heck of it. So I'm using this existing sprinkler timer from the AGW 2000 to work my days of week automatic mode. Now this is the contraption I came up with. The green, we're going to test it. We're going to see if it works. Maybe I don't know what I'm doing, but we're going to give it a shot. So this is my green light telling me that we are in forward mode. All right. So then we have, and I apologize if we get a little bit of echo in here. I've got the door shut because sunshine is so bright. And this is a manual switch to get it going. Now all we had to do is a little bit of wire, a standard 24 AC relay that I'm using to latch the switch. I'll show you the circuitry in a minute. But let's see if it works. We're going to go ahead and tell it to go manual mode on this. I thought I had this working on output 3 with its own schedule. I only need a minute to get it going. But let's see if we can make this work. If I can see above it. Let's do manual. All. And here we go. I don't know if you can hear it. Let's see if we can get a view in there. Turn the light on. You see the little red tick marks going? That's where we want the cam to come back around and stop. Now you can see it moving. We've now moved off. Our green light is off, and we have our red light that tells us we're in a backwash cycle. And I'm going to go ahead and hit pause when it's just about ready to stop. Now if you notice, the timer has timed out, and yet we're still turning. And I'll explain that in just a second when it comes back around to the stopping spot. Now we're just about to come around to the stop position. We are absolutely, like I said, out of time. We do have our cycle switch on. We should go to green when we get to the park position. And when we come around here, we should get the valve back where it goes, and it should all cut off. How about that? All right, now what I need to see if I can manually test it. Now what I would do is I'd push this button. This is a momentary button that should latch that relay, and that should hold it long enough to get that valve to rotate off of the park position, turning off the green light and turning on. Of course, the red light will come on when I push the button. But what I'm doing is getting it off of the stop so that I rotate all the way around in one full cycle, and at that point this thing can actually release after we get going. It doesn't have to be, it just needs to latch long enough to get around the stop position where that switch is not letting power go to the motor. Let's try it, see if it works. Okay, so we did see we got a latch up here. We got a start of a cycle here. Now once we get off of the end of cycle button, this should go off. And that's taking the valve out of position. There we go. Now we make one full trip around, and then we come back and park. Now I hate to drill holes in my perfectly good 20-year-old enclosure, but since I can't get the board, I went ahead and taped it off and painted it. And what I'll have to do is I have to cut 2 holes here somewhere and here probably, so that I can make me some labels and print under it manual, and then of course forward on the valve or normal, whatever I want to call it. Well, it may be a little farm engineered, but there we've got it. And of course, we did label it. Labels are crooked, trim the edges. Didn't work too swift, but good enough for government work, I think. Let's push the button, see if it works now that we got it wired up. Sounds like it. Let's go over here. Yes, we got water flowing.
Well, that's that. I know I spent a little bit of time on the wiring diagram. Remember, you do have chapter marks, so you can go look at any part of this you want to. And, you know, this is just, I'm just solving a problem, trying to keep something out of the landfill at this point. Appreciate you watching. Like a good puzzle like this. This is a little different than, you know, house wiring because you have to do some control, and it's not using computers, and we're not going Arduinos, and we're not doing Pis. We're not programming. We're just using good old common relay logic, and you have a lot of power with that kind of stuff if you can follow it. All the parts were Amazon, and we're done. And we saved out having to replumb that stupid filter or buying another one. See you next week.